Fluffs, what's up? It's good to see you all. Thank you all for coming. I'm glad you could make it. Yeah, it's good to see you guys. Tonight's gonna be an interesting one. Donkey dick tangents. Wow. But anyway, we've got Ryan S, Jeff Conkle, and PJ Cruikshank in the Element. How are you guys doing?
Oh, good. Somebody did ask earlier, if I missed something, what is Donkey Dick's tangent? Somebody asked that earlier, I can't remember who it was.
It's simply to state that the globe claims it bent tangent, so it's not a tangent anymore. But we're going to go through all that tonight. It's actually very simple stuff. If you understand what a tangent is, then you understand that you can't claim a curve. It's as simple as that. So everybody in chat, good to see you guys. Really appreciate everybody coming. Please do hit the like button and share the show. It really does help the show to grow. I do appreciate you all. I actually wanted to have a 4-hour stream tonight, but I decided against it because of the hectic week I've had at work. So I'm a bit tired. Maybe tomorrow night.
I don't blame. I'm quite glad you said you've got a mistake, because I'm tired tonight as well. I'm glad.
So yeah, and I've saving some data up and everything, so I'm able to stream when we gone down to the beach on holiday and stuff. So I at least want to do 2 to 3 streams. I'm looking forward to that. Streaming from a beach, really looking forward to that. We can do some observations.
That'd be brilliant.
That's cool. I get to see where you guys live.
But yeah, it's good to
I'm
see
kidding.
you guys.
I mean, like I get to see.
Are you trying to dox me, Ryan?
There, I might show up. I'm just kidding.
Oh, you can show up anytime. I think we'll have a barbie together. What do you guys say? Barbecue that side? Yeah, that's a braai.
About the wife and the kid, we'd have a blast.
Yeah. Okay, so guys, what do you think about the vote? 17 votes. A tangent requires a straight line touching a curve at a point.
Yep.
That's a definite yes, 88%. And no, I'm just stupid, 11%. So 11% of people are stupid. Wow. So at least 3 people are stupid, guys. Welcome.
Yeah.
Whoever thinks a tangent doesn't require a straight line touching at a curve at a point is not only ignorant, they're very, ignorant. I got no words for it, just stupid. Willfully ignorant, exactly. It's different when you don't know, and when someone corrects you on it and then you still take it as, run to be that, then it's woefully ignorant, yeah. So I'm just going to say hi to everybody in chat quickly. Aaron Nordstrand, what's up, man? Good to see you. Glad you could make it. Jim Smith, what's up? Good to see you too. Jeff Conkle, always good to have you in the house. Don Logan, hello. Glad you could make it. Ryan Est, good to see you too. Sean Hawkins, good to see you. Thank you for coming. By the way, Sean Hawkins wants to debate me, so just waiting for a date and a topic from Sean Hawkins. We'll see how that happens, if he's going to run away or not, like usual. Victoria, always good to see you, Vicky. Thank you for coming. Friday, hello, good to see a new name in. Thank you for coming. Who else did I see? I saw a few other names. Oh yeah, Spuddy, good to see you, man. Delayed choice, I'm glad you could make it. You're always welcome to come on the channel when you have time. No stress. And Anson Howard, hello. Yeah, I do try my best to stream as much as possible. You guys are really awesome, and I enjoy visiting and just having conversations with you guys. So yeah, you guys rock. Nathan Wright, good to see you too, man. Thank you for coming. Jeff Gassett, what's up, man? LJ in the house. It's good to see LJ. Glad you could make it. Always good to see you too. So I was thinking lately, what has happened to Face Reality? I haven't seen him in a while.
Oh, yeah, Face Reality, yeah.
Yeah. But anyway, shout out to Face Reality. If you guys do see him anywhere, let him know we do miss him. Yeah, and it's good to see Kiki's Seabass. He's still around.
Glad to see him still around.
Yeah, he's still a Patreon, so that's a cool thing to see. I really appreciate him. He said he's sending me some Christian material and stuff, so I'm looking forward to that. So shout out to Seabass, man. Kiki's Seabass, because I mean, at a stage we wondered what happened to the guy. He just vanished. Definitely. But he says he's in the background around, so that's quite cool.
Cool.
So yeah, it's good to see you guys. What is the the thing that's usually argued to you guys about a horizon based on a globe. Let's put it that way.
What is the thing? It's that it's refracted.
See,
Okay.
that it's too big.
It's not apparent that it's actual physical.
That's the thing. I usually get this so it's apparent and physical.
Yeah, that's it.
Yeah, so they try and play it both ways up. But when you take it to the globe math, it needs to be a physical marking. That means let's maybe go to I'm going to see if I can maybe get it up quickly. Advanced Earth Curve Calculator. You guys can see this on screen? I hope so. Yes, okay. See this horizon here. You see that green line? That would be a tangent line. You guys agree?
Yes.
Okay. So, what is a tangent? Anybody able to tell me?
Yeah, it's a point. It's a point where a straight line meets a curve.
Intersection.
Oh, so it's a straight line that touches a curve at a point. That's a tangent. So this would be the tangent. The horizon is claimed to be a tangent point. So in other words, does a tangent have a tangential plane?
Yes.
And can a tangential plane curve?
No.
Great.
Negative.
Exactly, Jeff. So, this is where the donkey dick geometry comes in. Have we ever had a day without refraction?
Probably not.
So it's always Atmo day, correct?
Yeah.
So, what do they claim this tangent line does with refraction? Yeah, I'll team up with Whitson on I'll team up with Whitson on MDD LJ. Got no issue with that.
Yeah. Be alright.
Yeah. I think it can actually be fun because we got two different views on things. But I mean, yeah.
If your last partner last time, he believed in ether and that. Not that it came up much, but it was a good teaming still. You know.
So there we go. Okay. Sparkly says that is curved. Are you blind? Let's zoom in for you. Maybe you need glasses. That green line is a tangent. There's the tangent point. There is no curve. Okay? Let's put refraction in. That's the refracted angle. Now it's curving. You see that dotted green line? Is that a straight line? No.
No.
So, the claim for your globe is the horizon is a tangent point. It's a physical curve. Now, if you have no Atmo day, which doesn't exist, so there's always Atmo, means refraction is always constantly there. So you have a curved tangent line, which means it's not a tangent. It literally throws away what a tangent is. And therefore, you cannot claim a physical tangent horizon. Get it?
We can never have zero Atmo day because we don't live in a vacuum.
Exactly. Now, let's say I've got a little bit of a conundrum for especially Sean Hawkins in chat here. Sean, on your globe, okay, let's just make this the ocean just for the heck of it. You claim you can have two spheres touching, so therefore it's a tangent. Great. When we stand out on the shore or on a boat or whatever and we look out, let's say we're just looking out, everywhere. If this is a curved line, it's not going to work, correct? Because that's not a tangent, because it's curving. It's going around a curve, as you would say. So that can't be a tangent. Now you're saying a sphere touching a sphere is a tangent. Okay. Let's put a sphere touching a sphere. Do we see this in reality, people?
I don't.
Has anybody ever seen a sphere touch a sphere in reality like this? Like we see some weird sphere touching the ocean.
No.
That would be a no. Hey, Sweet River Phil, good to see you. Thank you for coming. Sean doesn't seem to get it. Again, you're saying that the curve cannot be tangent to another curve. Sean, I'm literally showing on screen what an idiot you are. Again, let's go back to the maths, the calculator. Can you show us where a sphere is touching a sphere? Yeah, please, Sean. I don't see a sphere touching a sphere.
No.
But no refraction, straight lines. Refraction, bendy tangents. Ah. Hey Duke Nukem, good to see you, and Moxie7. So,
snooker maybe. Spud said, yeah, I suppose you see sphere against sphere in snooker.
Okay, I'm gonna try and explain this very simple to the likes of like Sean Hawkins. In reality, your globe claims a refracted tangential plane, which is insane because you can't have a curved tangential plane. A tangent plane is always parallel to the surface. It's a straight horizontal line. If you're claiming a curved line, it's not a tangent. A tangent, by definition, by geometry, is a straight line that touches a curve at a point. Now, you can have two spheres touching, which gives a tangential plane touching at a point, or a tangential plane touching at a point, or a tangential plane touching at a point. But where do we see two spheres touching each other at a horizon? In reality, Sean, we don't. No, a curve cannot be a tangent. Sean? We are talking specifically about a horizon. What is a horizon, guys?
It's where the sky and the ground appear to meet.
Appear, so that's apparent.
Yes.
Ah. Okay, let's just quickly do this just for Mr. Sean Hawkins. What is a tangent in geometry? Ooh. The word tangent means to touch. Uh-oh. The Latin word for same in tangere, in general we say that the line that intersects the circle exactly in one point of its circumference and never enters the circle's exterior is a tangent. Ooh. A circle can have many tangents. They are perpendicular to the radius. Let's us learn more about the tangent meaning theorems of article. Okay, so tangent meaning. Pay attention now, Sean. In geometry, a tangent is the line drawn from the external point or that passes through the point on the curve. One real-life example of a tangent is when you ride a bicycle, every point on the circumference of the wheel makes a tangent on the road. Makes sense, guys, correct? Because
Absolutely.
it's circle on circle, correct? Or circle on, this case in reality, a flat road. So let's imagine this line as a road and that the wheel. Let's do it this way. For Mr. Sean Hawkins, yeah? Hey Phil Bell, thank you for coming, man. Glad you could make it. Okay, let's do it this way. Ooh, that's the road. Now we're going to have a tire of a bicycle.
Tire. Do you need pressure for that tire?
Oh, yes you do. I would hope so. Otherwise you're going to have some real issues. Anyway, we're just making a rudimentary whatever.
What happens if the tire is flat?
So, where would the tangent be, guys? That would be a tangent, correct?
Yeah, like where the wheel point of the wheel.
And
it's a
that would
ground.
yeah, that would also be a tangent because it's the point that touches the curve from a straight line. Now remember this, you can many tangents, but it has to be touching. So the curve is touching at a point. Now you can put a tire on top of a tire. That's fine. And you have a tangential plane. Tangential line. Get it? Now, let's go back to the horizon. You claim the Earth is curving. Obviously, it's not to scale, Globies. You claim the Earth is curving. Okay. Now, if you're claiming I'm looking out to the ocean with a tangential line, this would be your X marks the spot, your horizon. Okay. Make it thicker. This would be your X marks spot. That would be horizon. That's your tangent. It's the line that touches a curve at a point. Correct?
Mm-hmm.
But since you claim refraction, that line goes like that. Not a straight line. So therefore no tangential plane. Therefore no horizon to be a tangent point. Got it? Always atmos, so always refraction. So this is where we say, are there any days without atmos? That would be a no. Sean Hawkins says there is no tangential plane unless you put it in there. A tangential plane is part of a tangent, Sean. If you put it there or not, it's there. It's the point. It's always parallel to the point. Tell us you don't know what a tangent is without telling us. Hey Glenn Selsh, good to see you, mate. Thank you for coming. Exactly. Whenever you're on a sphere, the highest point every direction is running away from you, because you are standing on the highest point and every point to the horizon is tangent from your feet, falling away from your feet. But that would require a straight line. Since they claim atmos and refraction, you never have a straight line, so you can't claim the horizon to be a tangent point. Therefore, it's called donkey dick geometry, because you're ignoring it's a tangential plane. I don't think I need to repeat this anymore again. I've kind of said it too many times. Well, that was a stream. Thanks, guys, for coming.
Check.
So yeah, what else do you guys have to say about a tangent besides taking us off on another tangent?
I was about to say, it's one of the things you can't say about a tangent is they take you off in different tangents.
Look at Sean, still not getting the argument. If I put a basketball on another basketball, where is the tangent plane? The point where the two basketballs are touching each other, Sean. Did you not listen? Now again, on your beloved horizon globe, where is your tangent if it is a refracted tangent? It's bent, so therefore not tangent. We don't have two spheres touching each other on your globe, Sean. Hey, Jose Nunez, good to see you, man. Thank you for coming. It's definitely flat in Oregon. Yeah, it's flat all over the place. Maybe we should do it this way. What is a tangent? Should we say what's a tangent for stupid people?
Yeah.
Maybe they don't understand that. What is tangent? Ooh. I might have to copy and paste. There we go.
In the event.
Ooh. In the event. Do the following.
Hi, welcome to Moo Moo Math. Today we're going to look at setting up a tangent ratio.
Okay, we don't need to set up a tangent. We can just know what is a tangent, because that's just tan. Notice that tangents are based on straight lines, guys. This is
Now, a tangent
really?
of an angle, the tangent of an...
What? What the hell? It doesn't want to type. What?
I've had that up before.
Yeah, it happens for some odd reason. Tangent lines and circles explained. Okay.
Hey there everyone, and welcome back to Mashup Math.
Hello.
My name is Anthony, and thank you for joining me on this mini lesson. Let's just go ahead and check it out.
Oops, he just showed a tangent there, guys, by the way. Okay. Mashup Math. Woo! Okay, let's see what he says.
So Bill says, are you confusing the path of light with the geometric notion of a tangent?
Horizon marks the spot. Maybe we should go back to the Earth curve calculator for him, because he doesn't seem to understand it. Okay, no refraction. Is that a tangent? Is that from your eye to the horizon? With no refraction. No refraction, you see? Correct? So that would be a line of sight to the horizon with a straight line. That's a tangent. A straight line touching at a point on a curve. This would be your physical Earth curve, people. Hey, Mr. Cheswick, good to see you, man. Thank you for coming and undoctrinated. What's up, man? Glad you could make it. And Jolly Man. Now, let's put your refraction into the mix. Oh boy, it bends that tangential plane. So therefore the X goes further away over the curve. So therefore not a tangent anymore, because it's bending donkey dick geometry. Hee-haw.
Hey there everyone.
Hello.
Thanks again for joining me on this lesson where we are going to explore the relationship between circles and tangent lines.
Ooh, tangent lines. Tangent lines, guys. Okay, we don't need to see what a circle is. We know what a circle is. Come on. Want to know what a tangent. There we go. Okay. There you go. Tangent line to a circle. There we go. Okay.
Point T. A tangent line to a circle is a line that intersects the circle at exactly one point. In this case, our point T.
Ooh. Is that a curved point? A curved line, guys?
No.
He said point T. Get it?
A pointy. A pointer. Pointer. Spherical cow, what's up? Charlie Welsh, good to see you. And backpedaler. Yeah. Globies or not, I agree. Donkeys are cool. Even Jesus rode a donkey.
Yeah.
Thank you, Vicky. Yeah, as soon as they mention people's children, they know they're not welcome. Very simple as that. That's crossing the line.
Now, if we construct a line that connects that center point P with that point T on the outside of the circle,
get a radius. Ooh.
We would be constructing a radius.
Ooh. A radius? Great. Okay.
And we can call that line R.
Ha.
So PT is a radius of circle P.
Nice.
And if we look at the angle created by the radius and the tangent...
Note, guys. An angle, two straight lines, meeting at a vertex, which be the tangential plane point on a sphere.
Line. We should see that this appears to be a right angle measuring 90 degrees.
Great. Something you guys don't have, remember? Because your tangential plane is curved, so no 90-degree angle to have a tangent to make a 90 degrees to have your radius. Oh no. Let's look if there's another video.
Sparkly Markley says, why do you call it donkey dick tangent? He doesn't understand.
Do I have to make this more apparent? You see that curve? You see that? Oh man. Do you see that curve on the? Yeah. I don't know. How do I make this apparent for you guys? How does it curve? Imagine a donkey's dick, in other words. Oh, well. I don't want to make it explicit content, so I'm not going to show it on screen.
Your visuals, you know what I mean?
Yeah.
You've got to use your imagination with this one, do you know what I mean?
Just...
It's sparkly markly.
I just have to state this out. This is an adult program today. No children allowed, please. Parental guidance advised. Imagine saying parental guidance advised for tangents. Crazy. So yeah, guys, it's very simple. A tangent is a straight line touching as a point on a curved surface. That's it. Don't know how much more clearer we can make this here. Hey, Lumpy Gas, good to see you, man. Thank you for coming. Even donkeys understand they don't live on a spinning space ball. Exactly. Those lines are the path of light. Refraction simply causes the path of light to bend. This means you can see the horizon further away. This would happen on a flat earth also. So, Professor Phil Bell, the horizon is an optical place then? Welcome to flat earth. If the horizon is just a path, apparent position on a in our field of view, and you're claiming it to be tangent, it cannot be tangent because you're claiming it to have a curved path. Curved path means no tangent. Which one is it? No Atmo day to give you your straight tangent, or it's always Atmo day, which gives a curved path, which means it's not a tangent, so therefore not a curved surface to have a tangent point. Therefore, no physical horizon. Always optical. No matter which way you look at it, Professor Fulbell, it will always be optical, never physical. What's up, Dislord? How's it going?
Hey guys, going well. Hope you too.
Didn't even hear you whoop in there. I was really sneaky, man.
You know how I do. You know how it is.
Stealth.
Sneaky.
Snacky, snacky, snacky.
Snacky, snacky.
Sneak-tastic.
And then you get the globies that say on a flat earth you have a tangent to a flat earth as well. Rachie specifically told me this. How the bloody hell do you have a tangent to a horizontal plane? Can anybody tell me this?
I haven't got a clue. I really not if it's horizontal, that's for sure.
No. It violates what the definition of a tangent is.
Yeah.
That point is not tangent to anything because you required it to be tangent, aka touching a curve. The earth is not curved, so therefore you can't have a tangent on a flat earth. Now they come and strawman and say, but then you can't have a horizon. No. A horizon in reality is an apparent position where the sky and earth appear to meet. Okay? Perspective. They want it to be a physical curve, but even in the geometry it can't be a physical curve because it violates the damn definition of what they need it to be. Just like when they try and change level to curve. They have to change what the actual definitions are to suit their belief system.
They sure like violating things, don't they?
Oh yeah. The way you say it. They love to violate things. Uh-huh.
Yeah.
It's crazy. But this is also why they don't get you can't see forever, because they love strawmanning flat earth and say, oh, if it was flat, you would always see infinitely far away. What bullshit is that?
No, that's just ridiculous. Ridiculous.
It's crazy. I mean, I can stand on a soccer field sometimes. If it's foggy, I can't see right to the end of the soccer field.
No, exactly.
Oh.
Yeah. Hey, Lev, good to see you. Yeah.
Even a neighborhood full of chimneys and, whatever. Something.
Yeah. DJ D, what's up, man? Good to see you. Glad you can make it. On a flat earth, you would also have a bent path of light. Dude, we don't need to worry about a bent path of light, Professor Phil, Because we don't have a tangent claim. You have a tangent claim. Get it? I love how he's trying to reverse the burden onto us. Has anybody here ever claimed a tangent to a flat surface?
No.
I've never heard anybody claim tangents to a horizontal plane before. Because that's not what a tangent is. She says, I didn't say you have a tangent on FE, lol. I said you use a so-called straight line, but there's refraction on FE. You false equivocating tangents to a flat earth because you're trying to say horizon requires a tangent, Raichi. By the way, good to see you. No, horizons do not require a tangent in reality because we do not have a tangent even on your model to have it claimed as a horizon, Raichi. Your geometry violates geometry, in other words. It's crazy.
Am I the only one who feels like deja vu right now?
Boo!
This is exactly like yesterday.
Ah, exactly.
Yeah.
But you see why we say the anti-flat earth is just nah. Goes in the one year, goes out the other year. It's like they literally ignore everything presented to them. They literally ignore it.
Nah.
Nuh-uh.
That's deja vu.
Let's go draw some flat earth on paint.
We literally and figuratively ignore it.
Okay, so let's draw a flat earth. This would be the water. Okay, now we got a guy on a boat standing and looking out.
Sean, the fact that you mentioned his kids, that's the point.
Yeah, so
Yes,
please just never... Yeah.
You weren't talking about them as in talking about them, but you mentioned the fact of his kids, so that's the point.
Yeah, so please, Sean, never bring my kids and my wife or anybody of my family into any argument or anything, because that is a plain disgusting move and you will be thrown in the bin. Literally. Yep. Okay, anyway. This line is not a tangent point. There's no tangent point here. Correct? Because what is the definition of tangent? A straight line touching a curved surface at a point. Can anybody show me the curved surface here?
No.
No. But it does represent a apparent position. Let's change the apparent position. How about to there? That's a new apparent position. Or how about another new apparent position? Has anybody noticed that they all sit on the same plane? Yeah, it's because it's horizontal. Hey, Matthew Eastman, good to see you, man. And Jonah Edwards, what's up? Glad you could make it. Into the break, good to see you too. So, Full Bell, does not matter if you don't worry about it or not. That will not change the fact you would have a bent path on a flat earth. What bent path are you talking about, Phil? Let's do the pressure gradient arguments for these globers that they usually love doing, correct? You guys ready for that? Let's say this part is denser than this part. This is just having some fun, by the way, guys. Just begging the question of columns of air. Okay, Full Bell. These are different density layers, as you like to call them. If I have light traveling and I'm looking down that way, let's say, let's make it orange. 8. If I have light looking that way, why would it bend?
Ooh, up now.
There's no bending in the atmo, Professor Full, because the atmo is not based on Snell's law, Professor Full Bell. We have deviation of light, you could say, due to temperature inversions and all that. We can definitely show refraction, but it's not due to Earth curve. It's just due to simple temperature inversions. Let's say here it's a bit hotter than here. So what happens when the gas heats up? It starts having more energy and it wants to go everywhere, correct? So it's moving around faster everywhere. So therefore it's less dense than the colder area. Now if I'm looking through here, and now it's denser, so it's just, you know, taking a little bit of a, and then it's still traveling straight. It's not like it's curving. So their globe claims that it's curving while taking a straight path. This is how idiotic their globe is. Let me draw it out for you. The Earth, the guy watching his light take a curved path through the medium. So if it's looking straight out, it only appears straight because it's taking a curved path. They literally are going against what we see in reality. Light travels in straight lines, Professor Fulbell. We don't live in a fish tank. Get it? Do we live in a fish tank, guys?
I don't. I've got one. I don't live in it though.
Okay, let's bring Snell's law up for these guys so they would understand what refraction is. There we go. Incident angle 1 would give you the equal to incident angle number 2. Okay, there we go. Incident angle 1 gives you incident angle 2. What is that? What's this line here?
Surface.
A medium.
Yeah.
Would this be air and water, for instance, or air and glass?
It'd be air
So-
water.
So media, two different media.
Yeah.
Snell's law gives us a relationship between the angles of incidence and the angles of refraction. When a ray of light travels from a rarer medium of index to a denser medium of refractive index. So you would need two separate media, correct?
Yeah.
Does it say anything about curved light here? Or are they still straight lines?
They're still straight lines.
Are angles two straight lines meeting at a vertex?
They are.
So when we have a quote-unquote ray of light which is straight, giving an angle, there's the angle, it just changes its incident angle through the other medium, which is still a straight line, Fulbell. So not curved light. On your globe, you claim this light curves. Get it? You literally go against what Snell's law teaches. Are you violating Snell's law now? Yes, you are. Well done. It only appears to curve in a fish tank. It's not actually taking a curved path. It's optical, mate. So yeah. Bent's not curved, Moran. Exactly, Jeff. Alright, you're bentful. Oh wow. And oh yeah, let's go look at some refraction. Great video again from Skyfree. They brought another video out lately. Have you seen it? The latest one?
Oh no.
Shout out to Skyfree. Let's
Dark marks keep coming back.
do that. Oh, that's bad.
Ooh.
Okay, dark
Definitely.
marks. Okay, sorry about that.
Get rid of them. Get some garnet.
Hi there. We have another observation for you. We're viewing from the same height above the surface.
Note, guys, they're always viewing at a distance which wouldn't give any, I repeat, any curve on your globe. And yet they're able to give demonstration of bottom-up obstruction. How is this possible on something that's not supposed to show bottom obstruction on a curve? Can anybody explain this? Oh, I know, refraction. So the refraction is causing the Earth curve. So that means the refraction doesn't cause things to appear over a curve. It appears to give it a curve, doing opposite of what your globe claims. Oh no, that's bad.
At the same body of water. The air temperature was around 34 degrees.
Cheers, Jeff. Good to see you, man. Have a good day at work further. Glad you could make it. Thanks for being here.
Degrees Fahrenheit. The water temperature 48 degrees Fahrenheit.
I just don't know about this music though. Check out that boat. Woo! Hey, Sea Lightning, good to see you, man. Thank you for coming. Glad you can make it. By the way, guys, thank you for supporting the channel. Please hit the likes, share the show. Really appreciate all the support. You guys rock. It really does help to get the show out to a further audience. The more you share it, doesn't matter where you share it on, just share it. It really does help. Thank you again. 42 votes, guys. That's a definite yes, 81%. Well done. We got some clever people in the house. And 19% of people don't understand you require straight lines for a tangent. Weird. They obviously don't know what an angle is.
We work our way down to a viewing height of about 1.5 inches above the water.
No, small changes in temperature cause the path to change incrementally. So not a curve then, Professor. Straight lines. Oh no.
Surface.
No, the small change in temperature causes the path to change. This is how mirage happens. Maybe you have FE explanation for mirage. Yes. The light causes the refraction to, how can I put this? Invert. So, if it's hot, it's going to give a certain wavy effect and it's going to make things closer appear higher as it's trying to move around because of the fast moving air molecules. There we go. This is why we see on a heavy refracted day things bending all over the place. That's also true, Paul. We'd first have to prove light has a path. Welcome, Paul. Thank you for coming. So yeah, that is kind of begging the question, to be honest. But we can demonstrate refraction causes bottom obstruction. Nice, nice.
Here comes the crack.
Yeah. Look, watch this boat go over a curve, guys. You're going to enjoy this. This boat's going to go over a curve. Notice, guys, if it was curving, would you have a mirrored effect like it's showing?
No. No.
Yeah, it's weird, eh? Still music. Wow, that's beautiful. DuckTales, woo! But Mubluff exactly into the break.
DuckTales. I remember that.
Yeah.
Ooh.
Where's the bottom of the ship now, guys? Is this boat flying in midair?
Possible.
It does look like it.
What is that?
People do believe in fantasies. It's possible.
Rachie says, refraction, you just made our point. So not physical then, Rachie. Welcome to Flat Earth once again. Are you conceding that the horizon's not physical, it's all optical?
Surely there must be here and there. He's sick of hearing that. So not physical then. Every time we say refraction, they must be sick of hearing. They must know it's coming. They must know it's coming by now, surely.
There's no such thing as...
They know it's coming, but don't care.
We just have to tell Phil Bell. He thinks it's new physics for mirages. No, mate. It's just light moves thanks to the excitement of the gases. Either it moves faster or it moves slower. Therefore, the light follows the path. If you're begging the question of light following paths. Ooh, look how beautiful that is. It's flying, people. Flying in the air.
Nice.
Remember, her camera is on the water. It's like as low as possible on the water. This is really awesome stuff. And it just keeps getting worse. Look at this. Is it going over a curve, or is it just having more and more refraction due to going further away to look through more of that excited air?
Yeah, I think the latter. More refraction, dude.
This passes as like a UFO image, by the way. Look at that. Can anybody tell us where the horizon is, yeah?
Yeah, you can't even see what's going on.
I have no
Is that a little hay hut?
Ooh. So it's gone over the curve. That's the horizon, correct? That would look like the horizon to you.
That would be the horizon, right?
But it's not actually, because it goes further.
Oh,
you
no,
see?
it's mirroring
Yeah,
there,
because the
actually.
mirroring. So it looks
Yeah.
like the horizon because it's the apparent position where the Earth and sky appear to meet.
Mm.
See? There it is. The
See, that's what I'm
mirror
saying.
line. Yeah, it's by the mirror line.
Mm-hmm.
So let's see, coming back. There we go. So it's not over a curve,
Wow.
or it's not flying in midair. Beautiful. Ooh. This is where you get Travis that was saying like the ether band kind of thing. This is exactly what he was trying to explain.
Is that a crazy duck? It did look like a crazy duck.
It did, yeah. Okay, so let's go look at some demonstrations from Skyfair as well. Actual demonstration. Now, there we go. I love this one. Again, shout out to Skyfree. Here's another. The globe is dead long, live flat earth. Exactly, Cheswick. Okay. I love this.
Focus on two objects during these tests. The yellow object was placed just under 14 feet from the viewer, at about 165 inches away from the camera.
Nice.
The green object was placed at 5 feet from the viewer, or 60 inches. Just to note, the surface we're viewing across is not perfectly smooth. There are slight undulations to it.
Perfect, just like you would expect over the oceans or over land, because there's things like little waves and things, correct guys? Because the
Yeah,
ocean is definitely have moving water, little waves, so you wouldn't expect it to be smooth, as in put it. But this is perfect.
The
for
center
that
of the
demonstration.
camera lens was about 1/8 of an inch above the surface during the observations.
Nice.
The green object is about 1/8 of an inch tall, and the yellow object around 3/8 of an inch. These first couple of observations take place between 11 p.m. and midnight. The outdoor air temperature was around 34 degrees Fahrenheit.
Nice.
The temperature indoors was around 74 degrees at the start of the test, and dropped to around 61 degrees during the test after opening the door to let the indoor and outdoor air mix.
Now remember, when what happens? Now you can see the green object and the yellow object. Remember, the yellow object's further away. Now, Globies, pay attention what's going to happen now with this, as you could say, apparent horizon. You see, this would be the horizon. Guys would agree with that?
Yeah.
That line, that would be the apparent horizon. So if we're looking out now on the ocean, and we say these are two boats on the ocean, we would say this is the horizon, that yellow object, boat, ship, or whatever, is on the horizon's edge. This would be the globe's tangential point. But since you're claiming refraction, you can't claim a tangent, so therefore you can't claim a horizon is Earth curve. Okay, so let's carry on, showing how this is only optical. Now, guys, remember, there's no refraction really going on now, correct? We can see everything. What's going to happen now when they let refraction happen? Let's see.
Here are the objects from the viewer's perspective at the start of the observation. And now we open the door.
Pay attention, Sean. I'm probably going to test you on this in the debate, mate. Uh-oh.
Ooh.
Oh, no.
Wonder what. Yeah.
Did it go over the curve? I thought refraction lifts things up, guys.
That's what it's meant to do, isn't it? That's what they say.
Huh. Maybe it lifted up so much that it took it out of camera's view. Globies in chat. Are you able to explain to us how refraction did not lift that yellow object up higher than the horizon? And also note how it's not refracting the horizon. Okay, but let's carry on. Beautiful. Just for the music's sake. Let it carry on going. Look at that. Oh, going away, showing a bit, going away. Always refraction, so no geometric horizon observed, Professor Fulbell, so therefore no physicality. Well done. Welcome to Flat Earth. Now, why is refraction causing this beloved apparent curve, guys? Can anybody explain this to us? Do you guys know in the panel? Because doesn't the globe claim refraction causes things coming over a curve?
Yeah, they profess to it lifts things up. Hence why we see the Chicago skyline lifted right up where it should be, like God knows how far back behind the horizon.
And I think the atmospheric temperatures and seas and things are quite almost constant in places, correct? So it's more at a average, constant average throughout the year and seldom changes. So when it has that seldom change, that's when you see the refractive.
Oh, I thought.
Yeah. Go ahead. You thought?
But it did quiet. I was like, thought lights disappeared.
Yeah, and he just said refracted when we.
I know.
Confused.
Are you still there? Are you there, Flash?
Yeah, I'm talking to you.
Oh, you are there?
Something weird happened.
Discord started talking, and I was saying, "Yeah, what you trying to say?" And then he stopped talking again.
Oh, okay. Because it went quiet for a minute, and I thought you disappeared.
No, okay.
Yeah, we didn't hear you.
Okay, say again what you wanted to say, Discord.
What did I say? I don't even remember now.
Something about refraction.
Oh, I was just repeating what you said because you stopped talking on my end.
Okay, no, I never. But anyway.
To try to make you say it again.
Okay, the point is, on a globe, they claim we see too far because of refraction. They say it rises the objects over the horizon. Okay? On a globe. So claiming it's not physical then, well done. But the issue is when we demonstrate refraction, it shows to create curve, not take away curve. So it's apparent. Remember, you guys don't even have a tangent, so you can't claim a physical geometric horizon because there's never been or observed geometric horizon. Has anybody in life ever observed a geometric horizon?
No. No.
I'm just shaking my head.
So why
you can't see that?
So why is the globus telling us that there are geometric horizons and measured for that?
Why do they tell us gravity is real?
Exactly. It's amazing how we can demonstrate opposite of what the globies always claim. And then when we present it, the anti-flat earthers like, great, you just say, nuh-uh.
But isn't the devil's version always the opposite?
Uh-huh. Exactly.
And flip this way or the other, and all this kind of shit.
Hey, JJ, good to see you, mate. It's all begging the question. Down. Exactly, Paul. That's exactly what it is. And TJ Waits, what's up, man? Good to see you.
Usually upside down and mirrored. That's that's typically how they do with logos too.
There we go. There's some more Earth curve. Woo! I love how the Earth is breathing, guys. Her floor's breathing. Yeah. She might need to get a poltergeist exorcist or something.
in hell.
Really weird. Okay, let's get some more demonstrations. Skyfree really has some great demonstrations. One of my favorite ones is this one. This will always be one of my favorites, by the way. Skyfree, you rock. Okay.
which made for some cool visual effects at home.
Yeah.
Here are the objects we're viewing during this video.
Hey, telephone, good to see you. Thank you for coming. Glad you could make it. So, there's a little bread tin tack, and there's little objects here. You can see they're quite small. Low to the ground. This is what I love about this, because it even shows the angle gets limited, and refraction just helps to limit it more, as it pulls the surface's apparent position up and pushes the objects down, creating the illusion of Earth curve, where the globe's argument always is no, it's doing the opposite. It's bringing it over the curve. Really weird. Yeah, Travis has some great videos as well.
Objects are placed about 210 inches or 17.5 feet from the observer.
Hey, Squirrel Sniper, good to see you. Thank you for coming. Glad you could make it. Professor Phil Bell, we are literally showing actual demonstration on why your globe religion is wrong. Why don't you go and show actual demonstration to provide evidence for your claims that the globe makes? The globe claims a tangent which cannot have a tangent because of donkey dick geometry. Then you go and claim it raises things above the horizon when we demonstrate it sinks things into the horizon. Get it? By the way, all the circles around you, optical. No physical horizon, no sphere.
And the center of the camera lens is less than half an inch above the surface. At the start of the observation, the air temperature at 4 feet above the surface was about 74 degrees Fahrenheit. And the temperature at the
begging the question, yeah. Begging the question's the way of the globe, Paul.
The surface.
Telephone, no, flat earth isn't a religion. Can anybody tell me the origin of flat earth, please? Hey, Tinshin, good to see you, man. Thank you for coming. But I know the heliocentric religion is a thing. It's a real religion. It's centricity. You're literally worshipping center of the sun. Helios, the sun god. That's the foundation of the heliocentric model, as you put it, which isn't a model. Religion. You believe you're circling the sun. You're orbiting the sun in a natural space violation. Yeah, that's a religion. You know why it's a religion? Because it's faith-based. You do not observe this. You just believe it. Flat Earth, on the other hand, we don't believe it's flat Earth. It is flat. Your whole geometry depends on it being flat. We observe everything in reality as flat and stationary. There's no other two ways about it.
Professor Phil says, find a video that shows you how mirages happen. Why will you not do that?
I'm busy showing you now.
Was around 73 degrees Fahrenheit.
Busy showing you now, Phil. Are these people, are they not doing mirages now, guys? Am I missing something?
Sure.
Am I missing something?
You must be.
The outdoor air...
Sorry?
You must be.
I mean, didn't we just have with the RC boat on the river, on the dam or whatever? Was that not a mirage? Was there no miraging there?
It was.
Oh boy.
What about when they claim a mirage is, what's the other one? The one where it's upside down? Superior?
Yeah, yeah, the superior mirage and inferior mirage, and then you get the the inferior mirage.
Yeah, there's so many. I bet they can't even explain any of them,
You see, the thing
especially
is,
not the superior.
no, they explain it, but based on the presupposition that the Earth is curving away, and it's lifting the light to bring it over. So it's causing a bent.
Okay.
Yeah.
That's
so,
a mirror effect. How is that even
that's
possible?
the thing. It's causing the light rays to bend, which makes it optically flat. That's what they say.
So we have a magical mirror in this
So they're
over
doing-
the water somewhere we can't see.
Yeah, so they're doing opposite of what reality actually is, where
My God.
the refraction is actually causing it to seem curved, not causing it to come up from the curve.
All right.
They're doing opposite. They want it to go up when it's going down.
Temperature was 7 degrees Fahrenheit. During the observation, when we opened the door and let the indoor and outdoor air mix, the temperature read about 48 degrees Fahrenheit at 4 feet above the surface, and the air temperature at the surface read around 40 degrees Fahrenheit. Here are the objects.
Yes, the floor remains warmer. Exactly, TJ. So temperature inversions. Great. So guess what? Refraction.
From the viewer's perspective at the
No, there's no such thing as bent refraction. Light travels in straight lines, straight paths.
start of the observation. And when we open the door to let the air mix.
Yes, they're opening the door to let the air mix. Watch this. What's going on? Why is it so wavy? Oh no, where's the bottoms of the tags? It went behind Earth curve.
Yeah, you pulled behind us.
Oh, this is funny. Wow. Look at that. Look. It wants to... no, it's going to pop her back. Oh, no. It's all gone over a curve. Oh, boy.
Yet I bet they will never seem like they're going sideways. Changing the angle in the air.
But note, guys, this is all just optical. That's the whole point. Let's see. Doing it again.
Now we open the door.
Let's watch it again. Wow. Really odd. Seems eerie similar to what we see over the ocean with boats, correct?
Yep.
Yeah.
Definitely.
Weird how that works. Here's another one.
We have more observations to come soon. Thanks for watching.
It's a pleasure, always pleasure watching your observations. Whoops. Skyfree rocks. Definitely go and hit Skyfree up, guys. I'll just stick the link again. If you guys want to subscribe if you haven't already, definitely well worth it. Shout out to Skyfree. You guys are awesome.
Why did the third object from the right get taller?
Because refraction. It stretches it. Okay, do you guys think they have understood yet that the horizon is the argument here?
No, I don't think so because no.
Okay, I think we have to go and see horizon definition.
If they don't get the black swan, then they clearly don't get it.
Yeah, they definitely don't get it. So, what is the horizon?
Horizon.
Okay. The line at which the Earth's surface and sky, what's this word? Appear to meet. Well, let's see what appear means. Let's see.
Seemingly. Seems to me, maybe.
Appear.
Come into sight. Become visible or noticeable, especially without apparent cause. Let's see what apparent means. This is like literally trying to we have to show children or something.
And it's in the word, you know, appear,
Exactly.
appearing.
Apparent.
Apparent. Okay. Clearly visible, yeah, or understood. Obvious, for no apparent reason she laughed. Seeming real and true, but not necessarily so. So, when we see boats apparently over the curve, or we see the apparent junction between the earth and sky appear to meet, it's not physically the earth and the sky appearing to meet. They're not literally touching each other. It only appears so. It's an optical...
Like with two laser pens.
Yeah.
Two laser pens doesn't, you know, you can't make them touch each other and stop them from going further.
Exactly. It's an apparent optical illusion. The sky and the earth are not actually touching one another. It's an optical illusion. So when you see boats go over quote unquote a curve, it's an optical illusion over the apparent position over the earth's surface. No physical earth curve. No tangent. No earth curve. Get it? So as soon as you say you have donkey dick geometry, you've thrown away your globe. You have no physical curve. And for those that just joined, don't know what the hell donkey dick geometry is. Horizon, straight line tangent. They claim this horizon is the physical earth curve. Okay? Let's take the refraction away. See where the point is on the curved surface? What is a tangent? It's a straight line touching at a point on a curved surface. If you put refraction, it pushes it further and gives it a curved tangent. So therefore no longer a tangent, because a tangent by definition has to be straight. If it's not straight, it's not a tangent. It's not a physical curve. Well done. And by the way, you need a flat earth to even do this math. Horizontal planes are the foundation. For even your radius requires a horizontal reference. Now I can breathe. Hey, Extra J, thank you for coming. So what else do you guys have to... I don't have to talk all the time, you know.
Well done. Well done.
Hey, Andres, good to see you. Welcome. Thank you for coming. So has anybody seen a measured geometric horizon?
Measured?
Yeah, they do claim that, don't they?
Yeah, they claim that, but never seen it happen.
Let's see, what is a horizon? How does the horizon work? Ooh, okay.
Oh, this is how.
I think Professor Phil wanted you to demonstrate or find out a citation on how mirages work. I think that's what he was.
We did it in simple terms. It's inversion
You know,
of light. There we go. Based on the movement of the gases. That's all. I mean, I can get citations that say men can be women. Does that make men women?
Exactly. It doesn't matter what you do, though. You can get up with, like, they'll find something wrong with it.
Yeah.
So, you can find something. Do something else.
I can say I can find citations that say gravity's a force. Does it mean gravity's a force? No.
Exactly.
It's crazy. These idiots don't get the internet talk shit, you know? Music. No. That's not a good thing. Okay, let's see. Hey, Josh Clark, good to see you.
This is Brain Stuff, and I'm here to answer a very pressing question. Have you ever been standing at the edge of water?
Okay, wait. I think let's maybe slow it down.
www. World Wide Web. That's 666.
It is.
Say, like, you know.
Hey, man, Dr. Sam. Well done. Yeah, you'll need gravity for that, and they don't have gravity. They don't know what gravity is.
Ocean and looked down on the horizon and said, I wonder exactly how far away that horizon is.
How far that horizon is. Okay, guys, now pay attention to what's going to be said.
You know, where the sky meets the sea, that's the horizon.
That's the horizon, guys, where the sky meets the sea. Okay. Is this physical or just apparent?
The horizon is just apparent.
On the globe, they want it to be a physical place where it meets.
Oh, yeah.
It doesn't actually. It never does. It's optical.
Apparently, it's not.
Well, it turns out because the Earth is curved, that it depends on where you're standing and how far above water you're standing. Let's say...
See what I'm saying? Tony Whitcomb, well, thank you very much for a £20 super chat.
It depends too.
Really appreciate the super chat. You rock. He says, a boat's necessity to travel needs level water to function. Yes. That's why locks are needed on elevation change. Exactly. Thank you very much for the super chat, Tony. We can really appreciate all the support. You are really awesome, man. You rock. Yeah, exactly. The whole function of a boat requires the water level to function. It's practically, even airplanes, everything requires level. The whole, I don't know, can anybody...
It's just a natural way of things that you need level to be able to work.
Look at anything in reality. Actually, the mechanics behind practically everything requires a reference datum of level.
Of course,
it's horizontal. Horizontal is the foundation for everything.
Exactly, you need level to be able to start anything, to begin anything, even to build. When it comes to mechanics, with building or anything.
I mean,
archaeology, anything needs level. Everything needs level.
I mean, let's for instance take everyday thing, maybe like building a body kit for a car. You're making angles. Those angles rely on a horizontal plane of reference.
Yep.
How about baking a cake? Okay, you're throwing it in a horizontal pan.
I thought of that one as well. I thought of that one.
Exactly, they're synonymous with horizontal, flat, level, plane, parallel. Exactly, spherical. But thank you again, Tony Whitcomb, for your super chat. Really appreciate it. You always require the horizontal for anything to be functioning.
And the cake needs containment as well.
Containment is the thing. Now, I love how this guy's begging the question of saying, oh, we have an horizon because Earth curves. No, I can show you an apparent horizon on my kitchen floor. Is my kitchen floor curving?
No.
No, I mean, I can go to my backyard.
I hope not.
I can go to my backyard in the day, and I can stick my camera on the ground, and I can show you an apparent horizon. Is my backyard curving? No. It's really idiotic, these people. Woody, we're talking about horizons here. I don't need to do geometry for straight lines, north, south, and east, west. If you want to do that, go ahead, Woody. We're talking simply about horizons here and how your horizon is geometrically impossible because you claim it to be a tangent. You don't have a tangent because you claim donkey dick geometry. And yeah, my kitchen's not a globe, Duke.
that you are in the water, right? And you're up to, say, your eyes are about 8 inches above the water.
Ooh, okay. 8 inches above the water. Great. That's a great start. So 8 inches per mile squared, which the globies don't love them to actually push, guys. Hey, rockets push off air. Yeah, it's idiotic globe codes.
Surface. Well, again, remember
that's the whole point, Tony. That's the point I'm trying to make. The globe can't have an horizon because they claim refraction. So you can't have a physical horizon because your horizon is based off of a tangent. If you're claiming a tangent, you can't claim refraction. If you're claiming refraction, you can't claim tangent. No matter which way you're looking at, you don't have a physical horizon, so you don't have a globe. Welcome to Flat Earth. Donkey dick geometry destroys the globe.
The Earth is curved, and despite the ocean seeming flat, they actually curve themselves.
How do you contradict yourself without knowing? Besides the ocean seeming flat, so they look flat, guys, they actually curve themselves. Can anybody show me a curved flat surface, please?
Curved flat surface?
Yeah.
It's a bit of a contradiction.
It's an oxymoron, yeah, that's oxymoron, isn't it?
Definitely.
Which, if you've ever really looked at the horizon, it kind of goes like this a little bit, which is pretty cool.
What? Why do we always get the globers fighting for toilet roll Earth then? Because they said only curves from me to outwards, yeah. So we live on toilet roll Earth, guys.
Wow.
But it also goes like this, right? So if your eyes are 8 inches above the water, right then you're about a mile away from that horizon point. Where
note, guys, this is going to bring the black swan into Modus Toland's back now, which you guys say is just a straw man. How is that a straw man if he's literally making a point? 8 inches per mile squared. So that would be based on the geometry of the globe, correct, guys?
That's right.
Huh. Okay. And he's seeing a mile away.
the sky meets the ocean, as far as you can tell. If you're standing up above water and you're like, I am about 6 feet tall, that means your eyes are about 5.5 feet above the water's edge.
Yeah. Okay. Tangents to what exactly, Price? Of Adam, exactly. Toilet bowl and pool. Sparkly still doesn't get the argument. You think refraction bends tangents? One last time. Your globe claims the horizon is a tangent point. That is the physical Earth curve point. That is the point that blocks boats over the ocean, blocks buildings, blocks anything that goes beyond that tangential point. What is a tangent? A straight line touching a curve at a point. The issue you have is you are claiming always refracted. So always refracted gives a bent tangent. So no tangent then, because a tangent cannot be bent. No straight line, no tangent. Always refraction, no tangent. No tangent, no physical curve. Welcome to Flat Earth.
A smooth ball has a curved flat surface. How does that work out?
He thinks smooth means flat, guys.
It doesn't.
No. You can have a smooth bowling ball, which is curved, but you can have a smooth tile, which is flat.
Smooth and flat are two different adjectives. They're not synonymous.
Wow.
Which means that you're about 3 miles away from the horizon.
Notice how he's giving actual distances. So he's giving an actual distance to a horizon on your globe, which would mean that's the tangential point of your geometry. Notice that?
Isn't that amazing?
I don't think Michael Jackson was singing Flat Criminal.
That's a good one. Flat Criminal.
Flat Criminal.
Wow.
It's just a flat criminal. Oh, wow. Hey, Oren, good to see you, man. Oh, man. That's, yeah.
From 8 inches above water, 5.5 feet above water, is the distance between 2 miles between you and the horizon.
See? Giving a physical distance to the horizon, guys. So as soon as you give a physical distance to the horizon, that would be this point. Let's go back to no fraction. That would be that point. That would be the physical. Okay? So, is the horizon physical? Can anybody answer me this? You got 10 seconds.
Oh, it might need all the 10 seconds.
Yeah, I don't think we need it. No, the horizon is not physical. Ooh, angles. Ooh, angles. So 2 straight lines. Well done. Okay, so refraction, bend tangent. No refraction, tangent. But since we never have no atmo day, refraction is always present. So therefore, you don't have a tangent. You can't claim physical Earth curve. Now, we move on to the black swan. We have... I wonder if I got it on here. Nah. Globe Terminator.
I can deny it, but it's true. I'll deny it because it's not true.
I'm gonna put QE site on for you guys. Shout out to QE. If you guys want to go and see it. Anyway, I want to go the black swan.
I forgot about that black swan picture with the pistols and that. It's quite a good one.
Yeah, it's quite cool. So, okay, guys, look at the modus tollens. Very simple stuff. Remember, the guy just told us a actual distance to the physical horizon.
Oh man, you're so funny. Oh wow. Oh wow.
So you guys would agree that guy just gave a physical distance, an actual distance of physical horizon. Okay, now let's move over to the black swan. If P, then Q. Okay? Not Q, therefore not P. Very simple. If the Earth is a sphere with a radius of 3959 miles, that would be P, then every horizon distance measurement must be no more than 1.225 times the square root of the observer's height in feet, Q. That's the geometric horizon that this guy is talking about. That is the geometric horizon he's talking about, people. Okay? He gave a claim distance of a geometric horizon. Okay. So, not Q. So, horizon distance, people. Horizon distance greater than 9.41 miles, therefore not P. Get it? So, the horizon was way more than the claimed geometric horizon would need it to be. What was the claimed height? 1 foot. So what is 1 foot? Times 1.22 times the square root of the observer's height in feet? Not over 9.41 miles. Where is the horizon in this still image? Way beyond the platforms. Way beyond the oil rigs. Remember, Globies, the oil rigs and their bendy cranes is not the argument. They are there for distance reference. The horizon is the argument. The horizon is way past 10 miles, which it can only be 1.22 miles times the root of the observer's height in feet. So in other words, 3 miles away would be the geometric horizon. Now, this guy's geometric horizon is 2 miles away at 5.5 feet. Why are we seeing this away over 10 miles at 1 foot? You claim refraction. Brilliant. So optical then. No tangential horizon then. No physical horizon. It's optical. No geometry. No radius of Earth. I don't know how clearer I can make this. Another black swan, exactly the same. Observer height, 8 feet. The max geometric horizon, physical horizon edge, is supposed to be 3.46 miles. Yet, it's past platform habitat, which is 10.10 miles away. So therefore, the geometry is not physical, and therefore you don't have a tangent because of refraction. You don't have a physical horizon. Welcome again to Flat Earth. And I think that's all I really need to say.
Fantastic work.
Did I make it concise enough? Did I talk slow enough?
Oh, that's
No, you're gonna have to start all over. I missed all that.
Yeah. Can you run that by me again? Run this by you again.
I got an idea. I got an idea. Oh, what the hell? Let's see. Refraction, you say? What the bloody hell is going on? Why is it doing this? Refraction. As soon as I press spacebar, it goes out.
Yeah, well, you shouldn't have, Aaron. I don't believe you should have a spanner just because you're a Patreon.
No, it's part of the. He's allowed to because
I
it's
know
part
it
of
is.
the Patreon.
I know
letter.
it is. But I mean,
Yeah.
but
remember, you must also remember McToon was also a Patreon, and what happened to him?
Yeah, exactly.
Yeah, if you do cross the line, Patreon or not, you will lose your range.
Yeah, Vicky was only asking where you've got a spanner is beyond that. And that's
Okay.
what I was just saying.
So
Beyond me
anyway,
as well.
yeah. So anyway, refraction, you say. So no. Oh, flip! This is irritating. No physical. Now it went out. What the hell is going on here? Okay, maybe we should do it. I'm gonna do it this way. This is gonna be much easier. Sorry, guys. File, new. Maybe Paint doesn't like text. Okay. I'm gonna try and make this as simple for the globies to understand. Refraction. Okay, we'll start off. Refraction, you say? Let's do it this way, actually. Duplicate. Yes. Duplicate slide. So, no tangent, no physical. So no physical tangent then. See how simple we have to actually make this for these guys. Tangents on a globe are impossible with refraction as it bends the tangent plane. Okay, now why can't I just move this bloody thing? Duplicate slide. So, no physical curve. No globe. Slideshow. Let's try this again. Refraction, you say? Yes. No, so no physical tangent then. Tangents on a globe are impossible with refraction, as it bends the tangent plane. So no physical curve, no globe. There we go. There's the debunk you guys wanted. And that's the simplest way I can bring it to these guys to understand. Because by definition, a tangent cannot have a bent plane. A tangential plane is always straight, flat, no curves. And refraction in your model bends this tangential plane, which means you do not have a tangential plane, which means no physical earth curve. Capiche? Okay. You guys want to say something? I mean, it's already 5 to 11.
I don't think those who doesn't get it will get it anyway. I think they will keep pretending that you can make straight lines, just shorter ones, and then you have to do one more short one, you know. I don't know. I don't think they will get it.
It's got to be the same for everything. Everything, they'll just compromise it down to the point that you can't do anything else with it.
They'll just keep making straight lines to where they think the curve is, and then make a straight line from that point and from the next point, and you know. Yeah. That's not straight lines then anyway. You know?
Yeah.
No, exactly.
And by the way, I'm going to be working on a video explaining spectroscopy, because Globers don't seem to understand what spectroscopy is and how it works. So I think I'll be doing a video explaining spectroscopy. Because they just believe Phil Bell on everything he says, even though he's totally wrong. Really weird.
He usually is, isn't he?
Yeah. So I'll do a video on spectroscopy trying to explain that. I just don't know how we are able to explain these simple things anymore. I feel like we're literally talking to a wall when we talk to these anti-flat earthers, because we just get blank stares back when we tell them about this.
Yeah.
So, yeah.
Well,
blank, confused, angry stares.
Okay, if you guys don't believe me how confused these people are, let's go look at Raichi.
Yeah, that is a good example.
That makes an amazing person, Alan. Brilliant. But I'll tell everybody why. Yeah.
Here we go.
Shout out to Raichi, by the way. My favorite anti-flat earth at this stage. Okay, where should we start? Flatzoid talks Coriolis. Okay, we've already seen that. This one. Tyson debunks Flatzoid and other flat earthers. Let's see how Tyson debunks me after I've made this exact argument, as it validates my argument. Okay. Okay.
Often think of.
I like this one. Okay. Pay attention now. Oh, but I might have to put it back to normal speed. Cool. Pay attention. I think you're gonna like this one too. Okay.
Planetary rotation. Does that
Does
that not engage with a field kick?
So if you have a north-south stadium, and many are, if it's oriented that way, and the kicker kicks the ball, depending on how high and how long it's in the air, the rotation of the Earth can have a significant effect on its trajectory.
Wait, what? Let's listen to that again.
significant effect on its trajectory towards the goalpost. If you're trying to make a 50-yard field goal, that's far away enough, and the ball is airborne long enough for the rotation of the Earth to deflect it to the right.
Ooh, Rachie shown wrong again. Yeah. Quite plain and simple. What was my claim? Not my claim. What was the argument? The Earth rotates underneath the ball, correct? Which gave it a deflection. Why? Because the goalposts moved to the right. That's what he said, correct? Did he not say that? I'm sure that's what he said. So the ball was not velcroed to the Earth. It moved in a straight line, and the Earth appeared to rotate underneath the ball. Literally point to point making my argument. Look at Rachie's response, guys. I can do this all night, people. Rachie, it's time to concede.
Good timing in the video.
Your argument is futile. You're literally making your name plank here. Is this what you want to do from now on because you claim to be a globe again? You want to claim true? You want to claim truth? That's why you're going back to the globe?
You want to claim truth? Is that why you went back to the globe? Is that a concession?
What? No. You want to claim truth, so you went back to the globe because you say there's not enough flat evidence. Yet when I present flat earth evidence and show your globe to be bunk, you just say nah-ah. So you're not showing truth, you're showing opposite. You guys would agree with that?
Yep.
Yeah.
Hey, Lil Spaz, thank you for coming. Good to see you. I don't push flat earth. It is a flat earth. There's a difference. No, Lil Baz, the globe is brain dead because everything based on your globe is literally la 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 la. Don't listen to what's actually presented and then just say nuh-uh, as Rachie likes to say.
The globe is truth.
Yet, you're doing exactly what the anti-flat earthers do and just ignore what's going on. Neil deGrasse Tyson literally says it here. Let's try this again. Let's listen to what they say again. Pay attention.
The ball, depending on how high and how long it's in the air, the rotation of the Earth can have a significant effect on its trajectory towards the goalpost. If you're trying to make a 50-yard field goal, that's far away enough, and the ball is airborne long enough for the rotation of the Earth to deflect it to the right by 1/3 of an inch. Cincinnati Bengals against, I forgot who was it, Seattle Seahawks, in overtime, sudden death kick, and the kick went up, and everybody's heart stops, and
everyone stopped. No one breathing, exactly.
No one breathes, and there it tumbles, and it hit the left upright and went in for the win, but kind of barely went in. And then I tweeted, I said this game was won, assisted by the rotation of the Earth.
You claim, he claims that Earth rotates underneath the ball.
Yep. What did he just say, guys? What did he just say, guys, in panel? Neil deGrasse Tyson.
Sorry, I
You
was
just said it. He just said what you said.
Exactly.
You said what she said you said.
I do.
So,
I see.
So the longer the ball is in the air, the more effect it will have as Earth rotates.
Up to 1/3 of an inch.
So the Earth rotates underneath the ball, Rachie, just as Neil deGrasse Tyson said. So literally making my point, Rachie.
1/3 of an inch equals 8.467 millimeters, which is...
And notice how Rachie's making math now and debunking the globe math. And trying to say it's my problem. Has anybody seen flat earthers make a claim on Earth rotation? Are we claiming the Earth rotates?
No.
So, do I have to give a shit what the math says of rotation?
No, we can't. No, it's there in any way anyway.
Yeah. So she's rebutting Neil deGrasse Tyson, the person that says the Earth rotates under the ball, and says it's my problem.
Yeah.
She is fun.
Opposite land.
Rachel, you might need to go back 10 minutes.
Equals 0.00001578 miles. Even if we say that ball was only in the air for 1 second, where do you think the speed on the globe is that small?
It doesn't matter. It's not our claim. You are debunking globe. Math? What? What? Tell me again.
I think in the globe religion it's opposite day every day.
Yeah, I mean, how is this? Can anybody tell me how this affects the flat Earth?
I don't know. Well,
Ryan, because Arvin, because I'm talking to my missus. That's why. Because you've just gone and caused trouble.
Dude, I think you should roll the ignore Aaron. I think he's trying to get under your skin, PJ.
Well, he's gone and caused trouble. That's what he's gone and done.
Aaron, this is a warning to you, mate. Stop being personal with PJ and Vicky, or I will take your wrench away, Patreon or not. Take this as a warning. Okay? Because I'm getting sick of this. Every stream, you are getting personal with PJ and Vicky. This is your last warning. Every time you're going to get personal, I'm going to take your wrench away, Patreon or not. Okay? Yeah, exactly, Vicky. Exactly. Yeah. So, see, Rachie says, shows you don't understand. So, what is Rachie doing? La 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 la. Nuh-uh. The idiocy of an anti-flat earther. Showing on screen exactly my validation of my argument, tries to debunk it with math for the globe, and then says, you see, the math of what I'm saying doesn't fit with the math what Neil deGrasse Tyson says with rotating Earth, so you flat earthers are wrong. No, Rachie, you debunking your own globe model here. Not that you have a model, but globe claims.
That equals 0.056808, so 0.05 miles per day. What were they doing? Playing at the poles?
Ooh, he's shown wrong again. It's time to concede. There, that's the video. Can anybody tell me how that debunked me or didn't make my point? No, it literally made my point. Now we can go to Nathan ruins Flatzoid's claim. No, Nathan didn't ruin my claim. Exactly the same thing.
Exactly by mentioning that it was going to cause trouble. You knew you knew it. You're a prick, mate.
Dude, ignore him. PJ, just ignore him. There we go. Rachie says, no, the math fits rotating Earth doesn't match what you think Coriolis is. There is no rotation of Earth, Rachie. No rotation. Anything else I can say, guys? What math for rotation if there is no rotation? You guys claim there's rotation, then you try and debunk the rotation with math, which shows your rotation wrong. Welcome to Flat Earth, Rachie. Rotation or no rotation is not our issue, it's your issue. You claim a rotation, not us. But now we move on to the Coriolis. So this is not Coriolis effect. This is Coriolis force.
Nathan Oakley, 1980. Coriolis force and Coriolis effect are one and the same thing.
Let me explain this quickly. Yeah, just like I explained it when he came on and talked. The Coriolis force is based on you being on the non-inertial reference frame. So the centrifugal forces, that would be based on the Coriolis force. Okay? Which would give a Coriolis effect as you are deviating over. But to have a Coriolis effect, you need to be observing the object moving in a linear fashion, appearing to take a deviated path in the inertial reference frame. We were saying the same things. I was just saying it, how can I put it, the wording differently. So I had to work out a more concise way to put it, as Nathan came and said, rather say it this way. We were saying the same thing, Rachie. How does this tie in with Coriolis force? Well, simple. Because of that tangential velocity and the conservation of the momentum, as you put it. Remember, it's still attached. The centrifugal forces is trying constantly to force the ball or this person outwards. So as it's rotating, you're getting a new vector. You get it? So it's trying to force the person outwards. So as it's forcing, that is a vector.
Your explanation, Flatzoid, doesn't work when she falls the opposite way.
Doesn't fall. Guys, what's she talking about? Falls the opposite way. Is the merry-go-round rotating? Do you know how centrifugal force works on a rotating reference frame, Rachie? It creates a new vector constantly. So. That's why it's acceleration outwards at 90-degree angles.
I remember those. That was the funniest thing.
And you know what I find? You know what I find very sad about this? She was the same one claiming this argument for Dell's rotating, accelerating Earth. Correct? Her acceleration was it could be like a pancake going sideways or something. I don't know. You know, swing ball Earth.
Did the merry-go-round now start spinning the opposite way? No, it didn't, did it? Oops.
Fictitious force. That's the Coriolis force. Because what's happening is it's forcing you outwards in a linear fashion. That fictitious force is just, centrifugal forces. Now, when you stick a bowling ball, for instance, on this rotating form, it's free to move, but it's still rolling on the surface. You will see it tries to push the ball outwards until it finally goes up. But it takes a curved path on that reference as it's rolling around. This is because of the centrifugal forces, which you call the Coriolis force. It's on the same reference. It's touching the turning reference frame. It's moving with the reference frame. In other words, it's still attached to the rotating reference frame. Now, the difference for Coriolis effect...
Nathan Oakley, 1980. Coriolis force and Coriolis effect are one and the same thing. So Flatzoid's report...
Again, saying the same thing. The only difference is, when it comes to the Coriolis force, it's based on the rotating reference frame. The Coriolis effect, it's based of you observing an apparent deviation on the inertial reference frame. We're saying the same thing, Rachie, just worded differently. Tell me you don't understand what's going on without telling me.
But all against my Flatzoid Talks Coriolis video was, again, difference between Coriolis effect and Coriolis force. What's that, Nathan? Coriolis force.
See, Rachie, full out. Look, guys, look at this comment. I think Flatzoid actually likes debunking himself. Can anybody explain how am I debunking myself?
I don't know. Fully flat. I don't get it.
I have no idea what she's talking about.
It's clearly opposite day in Globe World today as well.
I just, there's no hope for Rachie. She's literally, I don't know, is she taking drugs or something? Is there some kind of brain frying thing that's happened to her? I don't know. Is it even the same person? This was that. No, the apparent deviation comes on the non-inertial reference frame. No shit, Sherlock. The thing I've been saying for the last 5 minutes. For F's sakes, come on. Get with it. Clean those ears out. I said it. Literally. You observing a apparent deviation of the object moving in a linear fashion, only appearing to take a deviation in the non-inertial reference frame. The Coriolis force, however, is based on the rotating reference frame because of the centrifugal forces, like on a merry-go-round. Very simple stuff. They are insane the same thing. You have deviation. The only difference is the one is apparent deviation in the non-inertial reference frame, where the other one is a actual deviation on the rotating reference frame, Rachie. Get it? Because the one in the actual rotating reference frame has what you would say centrifugal force, aka a fictitious force, where in the non-inertial reference frame Coriolis effect, there is no centrifugal forces applied, no conservation of momentum, nothing whatsoever other than you moving, observing an apparent deviation. There's very subtle differences which you don't get, which Nathan just tried to come and explain, which I was saying the same thing, just in a different manner, which we have to try and work out to say it in a more concise manner to you, so you would understand. In other words, right hand, left hand. They both hands, just this is the right side, that's the left side. He's standing looking at me, this is on his right side, this is on his left side. Saying the same thing, just looking at it from a different perspective. Same argument, Rachie.
Force and Coriolis effect are one and the same thing.
I think this should become let's show Rachie's idiotic without knowing it. Oh, and this one, no denying this Flatzoid. I actually did a demonstration of video I'm going to release tomorrow, where showing she doesn't understand still. Do you guys want to go on with this, or do you want to do something else?
Nah, why not? She's going back and forth with you in the chat, so she's here. Well, let's do it.
Okay, let's do this quickly.
I don't wanna break.
By the way, guys, all thanks still for coming. If you haven't already, please hit the likes and share the show.
Okay, or insane now. I remember better days on.
Okay, so the next couple of videos from me and Flatzoid should be fun. Yeah, we're still going to be doing this. We're going to be making quick little videos, like you said, where she's going to present for Globe, I'm going to present for Flat Earth, and then we'll be debunking each other's. So my first debunk of this one will be tomorrow.
The playground, hoping I can find my way even when I'm feeling down.
You enjoying it into the break? I'm glad. Because somehow she thinks I'm debunking myself when I'm literally showing her to be ignoramus of the year so far. Okay.
Even when I don't know what is right, I'ma pick a side and I'ma take pride.
Music, sorry. Okay. Oh, still music. But in the meantime, let's debunk him again because it's just so fun. Okay, let's go. Okay, music. Okay, outside merry-go-round fastest tangential velocity. Like I said, correct, guys? Okay. I hope she talks. This guy throws the ball. Okay, yeah. Merry-go-round rotating to the right from his point of view. Does it rotate right underneath the ball, making the ball appear to go left or backwards? Nope. Notice where the camera is, guys. Is the camera spinning with this rotating reference? Pay attention quickly. According to Flatzoid, Oakley and the ball should end up behind the rotation. Has anybody ever said this?
No, I haven't heard that before.
No.
I haven't heard that.
So making shit up, Rachie. Well done. Okay. Debunked again. So you debunked a lie then. Well done. Because nobody's ever said that. Okay, go on. Notice how the camera is moving with the rotating reference frame, guys. Correct? So the camera is in the rotating reference frame, Rachie. Get it? The ball is being thrown straight, Rachie. Also note, if the camera was on the rotating reference frame of the merry-go-round looking upwards, the ball would be going to the right of the camera, but now the ball is up above the merry-go-round taking a rotation, so it is seeming to go to the left. This is all perspective. Just like we take the 6 and stick it on the ceiling and you walk to the other side, it becomes a 9. It's called the mirror effect. Yeah, hey Earth is Live, thank you for coming. But carry on. Carry on, Reishi, showing you don't understand location. Are those balls actually taking a curved path, people? Or are they taking an apparent curved path? Remember, the camera is rotating with the reference of the merry-go-round. Okay, it's not actually taking a curved path, it's appearing to. Okay, now to cover all the angles in case you don't say that's from the wrong frame, let's do this one too. Notice, here is not on the rotating reference frame. Still the music. Okay, watch guys, as he's throwing the ball straight. Oh no, the ball's going straight. He's appearing to move underneath the ball. Coriolis effect. Just like Neil deGrasse Tyson said. I can do this all night, people. It's time to concede. So how did that debunk me, guys? When it literally just made my point? Let's look at this again. As it travels in a straight line. Watch, guys. Straight line. Uh-oh. Is it taking a curved path? No, it's taking an actual straight path. The only way it looks deviating is to the person on the rotating reference. You not on a rotating reference, Rachie. Oh boy, the only person debunked ya is yourself again. You guys are allowed to talk, by the way.
Yeah, but you're doing your thing. You're doing your thing.
Yeah, you're doing so great. What are we gonna have?
Okay. Now, this, I'm going to be doing point for point on this. This is just...
You better watch out.
This is just... When I saw this first, I was like, what the hell has happened to you, Rachie?
Oh god, not that again.
Yeah. Look at Rachie. Like I said, you think you like debunking yourself. How the hell have I debunked myself, Rachie? Where I literally just showed you, verbatim, making my point. Okay, let's watch this, guys. Look how idiotic this is.
In a hurry.
Why the Earth is not flat and is a globe. Lunar eclipses can't be explained on flat Earth.
That's a lie. Well done. There's a difference between some of us don't want to make a claim about the lunar eclipse, and there's a difference between there are lunar eclipse explained on globe. Has anybody heard the words Rahu and Ketu before?
Yep.
Of course.
How many thousands of years has the Rahu and Ketu argument been out?
Always?
Much longer than the globe model belief system, correct?
Oh yeah.
Oh yeah.
So, already debunked, Rachie. Well done.
What making her point?
Or how about when you get some people say it's plasma, Rachie?
Plasma.
Huh. So there are actual arguments for an eclipse, but you just choose to ignore it, so, and then you say there aren't. So that's called a lie, Rachie. So you've already debunked on that one. Okay, next.
The globe can explain them. Check out these two videos from Dave McKeegan, which proves that ISS is real, in space, and no flat earther has even touched. I wonder why.
Sorry, no flat earth has even touched. Hasn't Sovereign Soul actually done anything on this before? What about Leo? There we go, that's why he's talking about Leo. So another pass there, well done. I just don't have time for this rubbish because it's simple.
I agree.
Yeah, it's simple. He hasn't provided evidence that you can violate the second law of thermodynamics, Rachie. Get it? Okay, let's go on.
No accurate flat earth map that maps the continents. Making an accurate flat earth map of the continents and the distances between them would be easy if the earth were flat. Alas, it is not.
You don't even have a map for the globe that gives accurate flat earth distances. Does she know this? There's not one accurate map in existence. She does know this, though, right?
Yeah, we are still speculating on the maps we think are the closest to reality is even close enough or even real.
Yeah. So I agree, there's no accurate map in existence for anything, Rachie. Note, all maps are flat. So there you're wrong again. Well done.
Flat. Apparently, ex-flat earther Tiger Dan found this out too. Who else knows that there is no accurate map of the flat earth and
Wow. FTFE proved me wrong live. FTFE picked up a globe and says it's a map when I showed on screen a globe is not a map, Rachie. Well done for another lie and another nah situation.
Look, it's a map.
I actually brought the video out. You know what? Let's just to show Rachie again. Maybe she missed it. Not that she did, because she was actually...
Overheard.
Somebody missed something.
By the way, guys, good to see everybody here. Thank you for watching. Thank you for coming. Let's go. Oh, not a live. It's a video. I don't know what's wrong with her. She's literally like become stick fingers in ears and say nah to everything. Globe is not a map. There we go.
Well, there's a rich...
2, 1.
So they're different, right?
And are you saying the gnomic maps are accurate?
No, I never said that in the slightest.
Okay, so it's another inaccurate globe map then.
It's a flat map based on a projection.
Great, just like all maps. It's flat.
Apart from the globe, of course.
Globes are not maps.
Google it right now. Google, while you've got Google there, please Google our globes maps.
Okay.
Because you seem to trust Google a lot for your...
Sorry?
No, because they have Google Maps and then they have Google Earth.
Yeah, but
it's not one. It's not in the same place. You know, it's two different, separate things. You know,
Rachie,
it's not one program.
Yeah, and Rachie doesn't seem to get a globe is not a map.
For your information, even though that
works. And Google Maps, that's flat maps all over the place.
A map is flat. All maps are flat. Rachie doesn't seem to grasp this very simple concept.
that's not really how Google works.
A globe is a three-dimensional sphere, while a map is a two-dimensional. The globe represents the whole Earth, whereas a map may represent the whole Earth as just a part of it. A globe can be used to get a broad level picture of the world, while maps provide more specific information about different places. Take it away, Anjana Mutta.
We will learn about difference between map and globe. First point, globe is spherical device, map is flat device. Second, globe is used to see whole world at a time. Map is used to see a particular region at a time. Third, globe is hard to carry, map is easy to carry. Fourth point, globe is three-dimensional object, map is two-dimensional object. Thank you.
It's a map, right?
Nope. A globe is a three-dimensional sphere, while a map is a two-dimensional.
So, is a globe a map? Yes or no?
By the way, Rachie, you can take a cube and stick those distances with those continents on a cube, and it will give the same distances as a three-dimensional globe. She doesn't know this. Do you know that? You can literally stick it on any shape and just stick the distances correct on any shape. She does know this, correct?
Of course. You could do it in a rhombus if you wanted.
Yeah. It will give the same distances because you're placing them with the distances you want on that particular shape. It's just really idiotic. Okay, but anyway, made my point. A globe is not a map. So Rachie, once again shown.
will admit it. Arwin does. In Arwin's description, though many flat earthers settle for a circle-centric dome enclosed world, I believe this is definitely not the case because of map scale inconsistencies. Even Arwin knows that there is no accurate map of the flat earth. because the Earth's not flat.
No. Arwen doesn't say because the Earth's not flat. So that's a straw man. Well done.
Crazy.
So in other words, misrepresenting what he says actually. Just like me. I agree there's no accurate map because there's not one in existence. But look how she misrepresents me too.
Even Flatzoid knows that there is no accurate flat Earth map.
Is between that point there, whatever that is X distance, and it would match real life. So whether there's a grid system or not on there is relevant. The fact is that the distances across the ocean between the land masses on the globe are correct, but there is no flat representation of the entire world that has the accurate sizes of countries and distances between them. The globe is the only that has that.
I agree, there's no actual accurate one.
The geometry.
So there's no actual accurate one. Does that mean now the flat Earth doesn't exist, guys? Because there's no accurate map?
No, exactly. It doesn't.
It doesn't match
Like-
flat Earth.
Yeah, it's like a big, nice nature park, and nobody ever mapped it. Does that mean it's not there?
Exactly. So the geometry doesn't match flat Earth and instead matches a globe. I just brought up on screen the economic map. Was that accurate? No. If he just said no, correct? What about the Mercator? Is that accurate? Yet they use the Mercator and the economic for navigation. So this is actually just ignorance from her part, which shouldn't be because she's actually been in this argument before. So I really find that odd.
And instead matches a globe. Oh, but elevation angles, I hear you say. Nathan. Yeah, sorry, your elevation angles match the globe, not flat Earth geometry.
What's an elevation angle, Rachie? A horizontal line. Your whole datum on an elevation angle requires horizontal, Rachie. It's flat Earth, not globe-based. Wow.
Geometry, mate. Just like why you can't make an accurate flat Earth map, because it doesn't match flat Earth geometry. The Earth is not flat.
So that's just... Nuh-uh. Let me just say it's not flat. That's exactly what she's saying. Because she doesn't know what an elevation angle is. That is...
Red is not red because I'm colorblind.
Exactly. That's practically what she's doing. She's literally just saying nuh-uh.
Nuh-uh. Can't have a curved baseline.
You can't have a curved baseline, Rachie. That's how angles work. The adjacent always has to be a straight line. What is an angle? Two straight lines meeting at a vertex. If you're claiming a curved baseline or adjacent, it's not an angle, Rachie. Maybe we should go back to Lumpy Gas in a Vacuum showing AutoCAD showing this. Or how about Jeff Durham showing this as well? It does not compute because it's not an angle.
Actually, you can. And you can have a tangent by creating a horizontal plane.
And this is what I wanted to say with the horizontal. Sorry, guys. You can have a tangent by creating a horizontal plane. So not a curved surface, which she just said is false, correct? Her argument was you literally can have an angle with a curved surface. All you have to do is create a horizontal plane.
What?
So, making the point, cannot have an angle with a curved adjacent baseline. Yes, you can if you create a horizontal plane. So horizontal plane, no curved adjacent, no curved baseline. Rachie. I'm speechless. I'm literally speechless. And again, on your globe, is a tangent curved? We've been through this in the beginning. You don't have a tangent on a curve because of refraction. Well done, Rachie. You're showing more and more. You just don't want to get it.
So, nuh-uh, black swan. The black swan is irrelevant to a horizontal/tangent line being created.
The black swan is the most obvious thing out there. It's embarrassing people don't get it.
Yeah, okay. Tell me, how's the black swan irrelevant to a horizontal tangent line, which this whole stream has been based on?
But even your attitude's changed, Richie.
Yeah.
You've got an
She's become troll. She's become troll. Her whole attitude has become troll-like. Literally. She's not taking anything serious. She's not even trying to listen. Literally just putting things on screen that validates what I say and then says, nah. I mean... Okay, so the black swan is relevant, Rachie, because it's about the horizon. The black swan is about the horizon, and that's why I brought that video out for you, to tell you it is relevant, because your horizon is claimed to be the tangent, the physical horizon. And because it's not a tangent, because it's curving, therefore it can't be claimed as a globe. So it's very relevant. You are just doing this. La 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 la. Nah. Not us. You, Rachie, going, nah. Nah. I made a mistake going to the globe. Yeah. Yeah.
And it's not like we like to agree, but we have to agree. It's true.
Yeah. It's sad. Because Rachie has literally made a dump on everything she's built up these last few years now. Literally showing she's being dishonest now. I got no other words for it. She's literally being dishonest because everything she's saying is literally nah.
Nuh-uh, because you claim refraction. That's not a rebuttal. That's just a stupid excuse to fool people who can't think logically. Flat Earth also would have refraction, you know. Does that stop you using the same horizontal line? Stop with the double standards.
Okay, and this as well. We don't claim tangents on a flat Earth, Rachie. Has anybody claimed a tangent to a horizontal?
No.
No, because you don't have tangents to horizontal planes, Rachie. So you are literally not only showing you don't understand what a tangent is, and you don't understand how relevant it is to the conversation, you also don't understand you are the one going nah when we explain to you donkey dick geometry debunks your globe. There's no double standard here. It's just us holding your idiotic argument to the fire.
60 nautical miles, or 69 miles per 1 degree of Polaris drop, matches the globe geometry, not flat Earth geometry.
Nautical miles was derived from people physically moving 69 miles away and seeing it drop at 1 degree. This is like a protractor, Rachie. You are seeing the celestial sphere. It's based on perspective, Rachie. This has been explained even by Brian's logic in great detail. If you don't want to accept it, that's not our problem. Heck, the Phoenicians actually did celestial navigation. They were flat earthers. Yeah.
Yep.
They sure were.
Yeah. Or how about the Vikings? Also did celestial navigation. Flat earthers.
Yeah. They all were.
Yeah.
And
Weird.
the Vikings' world was the world we are talking about. They were showing the flat Earth, and all the ancient worlds showed the flat Earth. They all had that model.
Yeah, and if Rachie doesn't get that you're looking at the celestial sphere and just taking those angles and transposing it down to put yourself at the center of the earth, which you are not at, is it not only stupid, it's lying to yourself. You do not take the observation to Polaris from the center of Earth. You're on the surface of Earth. You are looking through a protractor, in other words, Rachie. Hence why you get the 1 degree between every 69 miles.
I guess she wants you to show the actual northern mythology world map. No, not map, but
Prove Vikings were flat earthers. They existed before they even postulated a globe, Richie.
Yeah, and let's see their universe model. If you show her that, then there's no doubt it's the flat Earth.
Oh, I think I'll make a video on this for her. How's that, guys? Because, like I said, I actually want to go through these 10 points and make a video. Because this is really stupid.
24,901 miles divided by 360 degrees equals 69 miles per degree. The same rate the Polaris drops. Isn't that just so much of a coincidence?
Yeah. Remember that thing I did where I showed you standing under Polaris and you move away and it drops per degree because you're moving away?
Yeah, the old graph.
Weird.
Aaron, even the Egyptians was flat earthers.
Mm-hmm. Hebrews, flat earthers. Everybody in civilization, besides the Greeks they claimed, were not. Why? Because they loved balls. God had to create the sphere because it's a perfect shape.
No, it's because the Earth's a globe and not flat. You cannot make this work on a flat Earth using geometry.
Oh, really? Take a protractor. There we go. Debunked. Literally a protractor, Rachie.
Ever wonder why Nathan Oakley, etc. never shows how to get an accurate position fix from celestial navigation, even though they bang on about it like all the time?
I know, because that's not the argument. It's a waste of time to do this, because the argument is you require a flat earth to do your elevation angles. Elevation angles to get fix, flat earth. Trigonometry based on 90-degree right-angle triangles, Rachie. That's the argument. We don't need to show fixes because that's not the point of the argument. The point of the argument is measurements from a flat horizontal baseline doing 90-degree right-angle triangles to get your LOP.
I'm laughing with you, Alan Norstad.
Yeah, this is very funny. Vikings navigating from a ball. It's insane. I mean, what was their favorite way of navigating? A sundial on a ship, and what they had, a crystal when it was cloudy. So they used the sun's position over a flat earth. Really insane.
Ever wonder why he never gets past the angle stage? Maybe this is why.
My Australian friend was kind enough to share this dip correction table.
Oh, music. Dip correction table from an article. Let's have some fun and plot the lines of sight. Okay. Our height is 0 feet. Now notice, guys, this is making exactly, remember my thing I did, but inversed. There we go. Remember what I was doing with the projection of trying to put perspective into the orthographic view? This is just inverted. Literally. Why? Because what you guys do is you take yourself to the center of Earth and say, look, linear function from what? An equatorial plane. Idiots. I got no other words other than idiots. Look up what an equatorial plane is. That's all I need to say.
Well, seems close enough.
Okay, music still.
Interesting.
So, without knowing, they actually conceded here, begging the question, first of all, the radius, and taking flat earth measurements to create their radius value. Oh, wow.
What it says, the Baltards of history were fringe occultist trolls. And then Paul says, what?
Why is it using the nautical almanac matches the globe?
The nautical almanac simply is based on centuries of observation with times and dates. They then used it to correlate it with the Haversine formula. In other words, they took flat Earth observations and turned it into a globe mathematical construct, Rachie. Do you think if I work it out using a globe or not, the sun will still not be in that position over the GP of the Earth at that time and day? Does she think the stars and things don't move in a cycle that have not been observed for thousands of years?
Exactly what they are. They're cyclical.
They're cyclical. Yeah. Just like the Phoenicians I was talking about used the stars and their GPS to navigate over the seas. Flat earthers.
Because the Earth's not flat.
Oh, this music.
Nathan has resorted to talking about video games proving flat Earth. Even
video games do prove flat Earth. Do you know how the structure works of a video game, Rachie? Guys, last time I checked the environment they create in a video game, it's flat, correct?
Certainly.
Oh, yeah.
It's
So
a flat form.
yeah, the geometry
Flat
even
form.
in video games show flat. And when you talk about orbits, you require horizontal to be able to have an orbit, Rachie. All roads lead to flat Earth, as they say.
orbits apparently require
Sorry
flat.
guys, I would like to go on, but it's getting late and my wife is waiting for me. It's 11:45.
That's well lit.
Okay.
I mean, this is really stupid. All of this goes, even this rotation. It's saying it doesn't rotate that way. Just claw. Okay, see, I just told she came out. And then the mechanical drift of the gyro. Like I said, I actually want to do the videos on all this nonsense, but I think that's all we need to do tonight.
Yeah, man.
So yeah. What do you guys have to say before we close off?
It's been emotional.
Yeah, I don't know.
It's the usual, isn't it? It's not how we ever end. I mean, Sean set the standard at the start. Two curved lines can make a tangent.
I was going to say, what could we say that you didn't already cover? Right?
Exactly.
You did a good job, though.
So yeah, guys.
Not to say I couldn't probably talk about it for 5 more minutes, but you know, wouldn't be saying anything more than what you already said, though.
Yeah.
Good job.
But I think we made it very clear.
Yeah.
So yeah, guys, thanks for coming. I had fun. It was a good show. Hopefully the Globers will actually pay attention. And Globers, you're more than welcome to take experts clips out of this and try and make videos explaining how your tangent is still physical with donkey dick geometry. Yeah, would love to see that. Because it's, every time someone's going to come up, nah, refraction for Black Swan, I'm going to say donkey dick geometry, no tangent, no globe. All I'm going to say from now on. Yeah. So thank you, Tony Whitcomb, for your super chat earlier. Really appreciate it, Matt. You rock. And then the votes, they came out to 73 votes. A tangent requires a straight line touching a curve at a point. Yes, that's a definite yes. 79% smart people. And then we had 21% dumb people that said, no, I'm stupid. Yeah, you're definitely stupid. I agree. Yeah, so thanks all for coming, guys. Really appreciate it. I'll see you all tomorrow night for another epic stream. We'll see what we'll chat about tomorrow. Was insane. Please, guys, share the show. I really can't stress enough how it really helps. I want to say thank you, guys, and have a great evening further, and hit the likes. Many blessings. Cheerio. Bye.